Now we're going to do we're going to do a bar chart this time. The bar chart is a little tricky in specific ways, and I'll show why. In this case, we're going to change our bar chart just a little bit. I am going to, so I've run this chunk here already. I did create a table, and I wanted to see the county prescribing, and I did a frequency table by year. So it's outputting, it's not just graphs that it shows, it's the output for our other commands. So here you're seeing our frequency table that is shown here, the frequency of our values here. I wanted to see how many values are in each year and which years we had in our data set. Since 2017 is the most recent year, we're going to use that for this particular graph. We're going to do prescribing rates in 2017. Remember, as I said, prescribing rates are the average in this case, and we're actually going to open this. So county prescribing, I want to show you what it looks like, this data set. So each individual row is a county or a census area. They're called census areas, I believe, in Alaska, and they have a different name in Louisiana as well. So we have our county and our FIPS code, which is how I merged in the data. And then we have a lot of information as well. We have rural versus metro, our state, our region. Just FYI, I've gotten this question before. Where did I get this data? So in order to cite that data, I'm just going to go into my OneDrive. You would access this online, but this is going to look exactly the same. If you go into our programming class, you'll see data sources is listed here. Everything that I use, I add the data source to this file and re-upload and update that on the drive. So if you want to use this data, honestly, email me if you don't want to clean it, because this data does not export and look like this. This was a lot of work to get it to be clean like this. So, but you're welcome to use that for another purpose. But that's what our data looks like. So in this particular case, we're subsetting the county prescribing data set to 2017. And I'm also, the next thing I'm going to do is do an aggregate function. So the aggregate, we're doing the prescribing rate. We are finding the average prescribing rate across rural and metropolitan areas. So only for the 2017 data. And we have our mean function. We're using na.rm equals true because there's definitely NAA values in our data. We're changing our column name as we did before. So I'm going to go in and look at average prescribing rural. So this is the data we will be creating our graph with. So to start, we have that data that we just created. And we're going to create our bones of our graph, just like we did before. So we have our data. We have the data that we're using in our graph. We have X, which is our X-axis, which will be region. We'll have our Y-axis, which will be the average prescribing rate. And our fill, notice it's fill this time, not color, because they're bars and you want to use a set of fill color, is rural.metro. I'm going to show you the geom bar equals identity here. So that basically, because you could put and use our entire full data set, you could put stat equals mean in here, and it would give you the same thing that I did up here. And so you don't have to create your own data set, but we went over at the beginning why I recommend doing it this way. But I'm not going to cover that again. But this basically, all identity says I'm going to use the actual values and not find the mean or anything for that come from this data set. So we're using the actual numbers. Run current chunk. So by default, when you use the bar graph, it creates a stacked bar graph. In this case, that is definitely not what we want. But this is going to be the default until you change another setting that will be created with the geom_bar function. We go up here. You'll see here that, as I did before, I use geom_bar instead of geom_line and geom_point. So that basically tells it that we want a bar graph. But it created the stacked bar graph, which doesn't make any sense in this particular instance. So summing these together gives no information that we want. So how do we change that? In this case, we don't want a stacked bar graph. In order to change this to a regular group bar graph, we'd use this particular instance. This will be in the Excel sheet, so you wouldn't have to memorize it. But it's position equals position underscore dodge, and then we have our parentheses here. So that's the only change that I made in this particular graph. So now we have a group bar graph versus a stacked bar graph. So now we can directly compare our Midwest rural versus metro, or Northeast rural versus metro, so on and so forth. So now we don't have that stacked bar graph. I want to stop and give you guys a chance to ask questions if you have any. All right, I'll keep going then. So we have this now. Our graph is not stacked, but we got that ugly gray background again. We have gray tiny labels. We have our variable names as our labels. So we have to go through the same process that we did before. So in this case, I'm going to show you how to use a manual color set. So we have our prescribing, our object here, and we wanted to add, in this case, I use theme light. You'll see here that the theme light changes it to something that looks a little different than what we had before, but it takes away that our gray background and changes our lines in the background. So that's what theme light looks like. And we also have our scale fill manual. So when you don't use the scale color brewer, you have to set manual codes. I believe these come from HTML originally. So we put our values, and then in that vector, since we have two different colors that we're using in our graph, we set inside a string these color numbers. So if we go back to here, where did I find those color numbers? They're in right here in this individual, this image. So the only change that I make to these numbers is I put a £sign before them. But this is the reference that you would want to or could go to in order to get that color information. So in this case, I decided to use the light green here and the dark green here. So what I did in this graph to summarize is I added our light theme, and I changed our colors manually this time. Remember, this is fill, not color, because we have fill up here. So this created our bar graph, in this case, metropolitan and rural. Just to reiterate what the difference between color and fill is. So we are setting that fill amount here for rural.metro. So something we might want to do is change and put a black line around our bars. So if we change color equals black, so it would be the same color for both groups. If we rerun that chunk, run current chunk, now we have black outlines on our bars. So keep that in mind, and that reiterates what the difference between fill and color is. So in this case, I don't want this, so I will get rid of it and rerun that chunk. So the next thing, just as we did before, is we are adding our title, our legend title, region, and as our axis title, and for our Y is mean prescribing rate. So in this case, we are graphing average state prescribing rate per 100 persons. And then remember, this dumps it on 2 lines instead of 1 by region and rural status, 2017. So how to get that rural versus metro, those were merged in with those FIPS codes. And the rural versus metro is from the USDA. And if you look at the sources, you can see where that came from. So we set it with the labs again. So title, as we remember, is our plot title. Fill is our legend title, which also corresponds to what's written up here. Y is our x-axis, and X is our x-axis or our horizontal axis. Y is our vertical axis. So I added those in. That's the only change I made. So now we have, instead of our variable names, we have a title here. We have our labels here. Our is here, and we now have more easily understood information on our graph. But there's still, the sizing is off and they're still too small. So that's what we will do again. So as before, I put the plot.title. Since we're changing text, we want it to be element underscore text. I wanted the size to be 14 again. I centered the plot title and I made it bold. Face equals bold is bold. Separated by a comma, come down here, axis title, element underscore text, size 13 in this case. So this will be our axis titles. The next thing that I'm setting here is our axis text. I have our element.text again. We set the size with size equals 12, and then color equals black. So that changes it from the gray to the black, so it's more legible. The next thing we would change is legend.title. So this is going to change our legend title. And we will have it as size 13. And then our legend text will be size 12. Again, we have a lot of white space here that's not being used, so I'm moving our legend to the bottom. When I run that, we now have a centered bolded title. Our mean county prescribing rate is here. All of our labels are much bigger and a lot easier to read. Are there any questions? Okay. So remember when we talked about Claus Wilk, he said to order your bars by their magnitude. That's what we're going to do here. So in order to do that, we would just basically pull up our data set that we created this. So our average prescribing rates. I would, in this case, they might be different, or they could have been different. So Northeast, one could have been up here and the other one could have been down here, but it didn't end up that was the case here. So it was a really straightforward way to do this. The Northeast is always smallest and the South is always largest. So we'll start with the South, list the West, list the Midwest, and then list the Northeast. So that's what we did here. South is listed first, West, Midwest, Northeast. So we did that again because it can be reordered with that factor variable. And then we will put that region into, it will update in our graph basically and reorder those values. So that's the only thing I changed here. So now our largest is South, our lowest is the Northeast, and they're in the same, in descending order. So I am satisfied with this graph. It's what I want. So I'm going to export that now. Excuse me. So just as we did before, we're using ggSave. We have our file name here that we want to set. This time I'm showing PNG, and how you would make, instead of a JPEG, you would use PNG as our file extension. That's up to you. Set whatever you want right here. The plot that we're exporting, so the object that we're exporting, our width, our height in units, inches, and our DPI is 300. So if you go in, our I will rerun this just for clarity. Now, rural prescribing bar is in our working the file path that we mentioned, and it's exported, and it's in an object on our computer now. So you can see now that we've gone through 2 exercises, it might look complicated, and it is complicated, but our bar graph is very, very, very similar, the code that we used, to the line graph that we created. There's very little differences here. The only differences really are in the geom bar part. So if you can do one type of graph, you can do another.